All right, guys. We are graphing quadratic equations in Vertex form. This is your test review. Please make sure that you have already attempted this test review on your own and that you have checked your answers on just the pictures of the key that I have on the classroom. Please don't just sit down with a blank review and watch the video. If you haven't done that, please pause this now and go attempt it on your own. Because you're not going to have a video of me doing the test tomorrow in class, right? So remember that we are graphing quadratics in vertex form, and that vertex form of quadratics is y equals ax minus h squared plus k. Remember that a controls reflections and vertical stretches or shrinks, that h controls movement left and right, and that k controls movement up and down. All right, I'm looking at this parabola right here, and the vertex here is -3, -4. And I'm going to go ahead and put that vertex in the middle of my table. Remember that your tables need to be in numeric order in terms of the x values. So if -3 is here, then above it needs to be smaller numbers. So that would be -4, -5, and -6. And below it are larger numbers, so -2, -1, and 0. The way that we graph this parabola, you can use a calculator and look at the table and find a table of values and graph them, or you can use the pattern that we have to graph quadratics. I'm going to be using the pattern. Remember that if you write this pattern on your test, that you will get bonus points for every time you write the pattern correctly. You have to write the correct pattern. So, because this does not have an a value, we can use our standard pattern, which is out 1, up 1, out 2, up 4, out 3, up 9. And that's our standard pattern. So I'm going to go ahead and graph my vertex, and then I'm going to use this pattern to graph the other points. So out 1, up 1, out 2, up 4, and out 3, up 9. Remember that this is not a parabola until we have connected the dots. Now it's a parabola. We get the other values for the table from our graph or from the table in your calculator. So I'm looking at my graph, and at x equals -4, the y value is -3. I have that same y value at x equals -2. At x equals -5, the y value is 0. Again, same y value at x equals -1. And at x equals -6, the y value is 5. And again, that's the same y value here at x equals 0. Please note that this is the vertex right there in the middle of our table. You should notice that there is symmetry in the table, meaning that on either side of the vertex, the table is the same. -3, 0, and 5. All right. We have that symmetry on the graph as well. On either side of the vertex, the graph is the same. Because of that, we have a line that we call the axis of symmetry that we draw down the middle of the parabola to show that we understand that it's symmetric about that line. The axis of symmetry is, in this case, at x equals -3. Your axis of symmetry is always at the x value from your vertex. The direction of this parabola is up. The zeros on this parabola where it touches or crosses the x-axis, those are right here at -5 and -1. You can also see those zeros in the table where y is 0, that's why they're called zeros. Those are our zeros, so -5, 0, and -1, 0. The domain of any parabola is -infinity to infinity. The range of this parabola is -4 to infinity. And the transformations that have happened is that this parabola has moved left 3 and down 4. Now on our list are two other attributes that we need to identify They're not listed here, but they are on the list of things that we will need to be able to identify. And that's the y-intercept. And the y-intercept is where the parabola crosses the y-axis, and that y-intercept is right there at 0, 5. You can also see that in the table where x is 0. See, it's right here. Where x is 0, that's the y-intercept. And then you also need to be able to tell me whether this parabola has a maximum or a minimum. This parabola has a minimum. It's got a minimum value, and that minimum value is -4. That's the lowest point on the graph at -4. And that minimum value happens at x equals -3. It's got a minimum value of -4 at x equals -3. And if those numbers look familiar, they should. All right, guys, I want you to take a minute right now to make sure that all of your information looks exactly like my information. We are precise in mathematics. We expect our domains and ranges to look exactly the way they're supposed to, okay? So please take a minute and make sure that your information looks exactly like my information. If you're missing a sign, fix it. If you've got two numbers flipped, fix them because it's not the same point. For example, if you have 0, -5 right here, that's not an x-intercept. So you need to fix it. If your domain has the -infinity over here, that is wrong. It will be totally wrong on the test tomorrow. You need to fix it. If you don't have a bracket on your range, that is wrong. You need to fix it. So just take a moment and make sure that all of your information looks exactly like my information. All right, moving on to question 2. The vertex of this problem is the point 1, -3. I'm going to go ahead and graph that point 1, -3 right here. Now for this problem, we have a multiplier of 3, So our pattern is not going to be out 1, up 1. It's going to be out 1, up 3 times 1. Out 2, up 3 times 4. Out 3, up 3 times 9. Because of that 3 right there. So we multiply our ups by 3. And so this is going to be 3, 12, and 27. I'm going to go ahead and put the vertex in the middle of my table, and I'm going to organize my x values around it. So above it, we're going to have 0, -1, -2, and below we're going to have 2, 3, and 4. I'm going to go ahead and use this pattern to graph the other points. So out 1, up 3, out 2, up 12, which is right here. And unfortunately, we're not going to be able to graph that last set of points because it's going to be way off our grid. Up 27 is a little out of our range. All right, so that's our parabola. I'm going to go ahead and draw our axis of symmetry through the middle. That is part of the parabola. It's part of the parabola. And in this case, the axis of symmetry is x equals 1. Remember, that's always the x value from the parabola. This parabola is opening up, and the zeros are at 0, 0, and 2, 0. The domain of this and all parabolas is -infinity to infinity, and the range of this parabola is -3 to infinity from the vertex right there. Transformations that have happened to this parabola, there is a vertical stretch of 3. It's moved right 1 and down 3. Those are our transformations. The additional information we want the y-intercept, and that's in this case right there at the point 0, 0. And this parabola also has a minimum value of -3 at x equals 1. Now I still need to fill in my table, and we fill in the table from the points that we've graphed here. At 0, my y value is at 0, as it is at 2. At -1, my y value is 9, as it is at 3. And then that 27, if we start at -3 and go up 27, we end up at 24. And again, you can do that math, or you can use a calculator to help you find those values if you need to. Again, take a moment to make sure that your information looks exactly like my information. Make sure it looks exactly like my information, that you don't have any of the numbers flipped or anything. All right, moving on to question 3. Guys, isn't this fun? All right, this parabola has a negative right there, which means that instead of going up when we graph points, we're going to go down. Isn't that good times? The vertex for this one is -3, -1, and I'm going to go ahead and throw that in the middle of my table. I'll write my other x values here. My smaller x values are -4, -5, and -6, and my larger ones are -2, -1, and 0. I can go ahead and graph my vertex at -3, -1 right there. And my pattern, because this has a negative, instead of going up, we're going to go down. So it's out 1, down 1, out 2, down 4, out 3, down 9. And so I'm going to use that pattern to graph my points. So out 1, down 1, out 2, down 4, and then out 3, down 9. And that parabola is reflected. It's reflected. We'll go ahead and fill in our table now. So at -4, my coordinate is -2. It's the same for -2. We're at -2. At -5, my coordinate is -5. And that's the same for -1. And at -6, my coordinate is -10. And that's the same for 0. Remember that we have to draw the axis of symmetry through our vertex. And so for this parabola, our axis of symmetry is x equals -3. The direction of this parabola is down, just for some variety. 0. 0 is where the parabola touches or crosses the x-axis. This parabola neither touches nor crosses the x-axis, and that means that there are none. You can also put non-applicable. You can say there aren't any. You can say it doesn't touch the x-axis. Just make sure you write something there that indicates to me that you know what's going on. The domain of this parabola is -∞ to infinity. The range is -∞ to -1. And since this is a reflected parabola and has a negative right there, that's how we know that we start with -∞, because it's got the negative right there. You're going to start your range with -∞. All right, transformations. There's a reflection over the x-axis. It has moved left 3 and then down 1. We still need to identify the y-intercept of this parabola. The y-intercept of this parabola is 0, -10. And we do need to talk about mins and maxes. This parabola has a maximum value. It's right there. So we have a max of -1 at x equals -3. A max of -1 at x equals -3. Again, just take a moment to make sure that your parabola and all of your information looks exactly like mine, because precision in mathematics is not optional. You have to make sure that you are stating your information correctly. All right, on to the grasshopper. So we got a grasshopper who's hopping from place to place. This is a terrible parabola. It's not symmetric. It'll have to do. This function models the jump of a grasshopper, where x is the horizontal distance in inches and y is the corresponding height in inches. What we are going to do is we're going to look at the jump of the grasshopper. Remember that this is vertex form and that the vertex is the point 525. That's our vertex right there. So it's right here in the middle. And if you look at this point, guys, 25 is our height and 5 is our length, which means that my parabola is not drawn to scale. Again, we're making it work. What is the grasshopper's maximum height? Well, that's from the y value of the vertex. That's 25 inches. And how long is the grasshopper's jump? Well, the grasshopper doesn't jump to the vertex and then fall to the ground, right? The grasshopper jumps in an arc. So he goes 5 feet to the vertex and then 5 feet till he lands again. And so that's 5 plus 5, which is 10 inches. All right, lastly, a pogo stick. And so our pogo stick jump can also be modeled by a parabola. I'll draw this one a little taller. Okay, remember that this is vertex form, so the vertex of this parabola is at 516, which is right here. And the y value is your height, so that's 16. X value is your width or your distance, and so that's 5. So the maximum height of this jump is 16 inches. And the jump, again, this person doesn't jump to its maximum jump and then just fall to the ground. We come down gracefully, just like we ascended, we descend gracefully. And so that's 5 plus 5, which is 10 inches. What is a reasonable domain and range for the jump? Well, we start the domain at 0, and that person jumps for 10 inches. So we start at 0, and we come down at position 10 over here. And the range, well, that person starts at 0, and they go up in the air to 16 inches, and then they start coming back down. So our range is 0 to 16, like that. All right, guys. I hope you have enjoyed this test review. Again, please go back and double check and make sure that you're writing all of your information the way it's supposed to be written, so that your stuff should match up with mine exactly, because that's how you're going to score the points on the test.